Because at work, your manager will ask you this question: what process is using this? And then you start scratching your head. Hold on, let me use the restroom. Let me go to the bathroom. I want to use the restroom. I'll be right back. Then you go and start calling my number. Look up, guys. Listen, it's very simple. When they ask you, it's a common thing. Systems, your job at work is to monitor systems, right? They can ask you which of the processes are using the highest memory. You might not see this on the monitoring tool in the front easily. It depends on the kind of monitoring tool you guys have. So you have to come to the back end on the system itself. And on this system, there are two commands. You can run this command. The first one I gave you before, the top command. If you run the top command, this is what comes up. These are the processes technically where you see command here. On the right side here, this is what we call the processes. And these are the ID. If you look at the ID number 1, it's always system D right there. If you look at the name of system B, this system D, and the ID here, PID, is always 1. Always 1. It will never change. Now, but these are some other processes here, other things that are happening on the system here. Don't worry about all of them. You don't need to see, please don't remember any of these names here. They will ask you which process is using more CPU or memory. You will come and read it. I'll show you how to see that. Now, it's possible to do that here. You do, oops, my bad. Let me open it back. Sorry. Pay attention because I want to show you something. I'll come and read the memory here, but this is not the best tool. That's why I tell you guys to install HTOP. HTOP is very practical. Please watch this. Watch this. Because I have a lot to do on this page here. A lot. I want to make you like it. I told you before that when I teach you this thing, you understand this page. You'll be a child's play. Please look up. I can run the top command, or let me do Q for quit to quit, clear my screen, or you do HTOP command. You run the HTOP like this. HTOP. When you run HTOP command, this is the HTOP. I prefer the HTOP command. You see, it shows us, it will show us good stuff. And you see, look at, let me zoom a little bit out. You look at this line. You see, it says here system D. This line with 1, ID 1. This man, ID 1. It's always what system D is running away from me. It's because they are changing resource usage. And you see here memory, CPU, memory, right? If I want to know the process is using a lot of memory, listen carefully. The process is using a lot of memory. This is mem percentage. This is CPU percentage. Do shift, control, is it control M? Oh, shift M. I'm always playing with these two keys. Shift M. If you do shift M, you look at this. If I do shift M on my keyboard, it will filter it according to the memory. The one with the highest usage, memory usage, right, will be at the top. And that is cockpit. Cockpit is using a lot of memory. Maybe because some students are using it or some people loaded it and they just left it open, which is fine. But I want you to see that this is right here. This is this particular process using a lot of memory. So if you don't know, your manager asks you, Jasper, can you tell me the process that is using a lot of memory on your system? Come on this, run the HTOP command, do do shift M, then you take a screenshot and send it to him. He will read it. That is assuming that you don't really know how to read it, right? Just do shift M, take a screenshot and send it to him. You never go wrong. Because he will look at it, he knows that you actually filtered it from the highest memory usage to the least. Then he will understand that, okay, cockpit is using a lot. You see 22.7% of the memory is used by cockpit, right? Then 11% for what? Cockpit breach again, still cockpit, right? Then this 7% is package kit, for example, right? 4% for cockpit breach again. 0.6% for what? FAP policy, right? And so on and so forth. Are you getting logic in it? We are so concerned about memory usage. We don't really so much worry about CPU because it's not something, CPU is something that goes with memory. When the memory is overloaded, that's when the CPU gets to struggle. Do you agree? Because if there are too many things on the memory, the CPU has to address them. But if you clean the memory, the CPU will have little work to do. You get logic in it? That's why he will ask you for the memory usage, not the CPU usage. Good. God bless all the students in this class who are multitasking. I can see it. You are here, you are there, you are multitasking. What are you doing? Only God knows. And I feel sorry for you because very soon I'll ask a question here and then I'll say, okay, anybody else say you get $50. Then you'll be like, can you ask it again? Yeah, you're not paying attention. That's why you do not get it. Okay? Please pay attention. It's easy to know. It's easy for you to report yourself even to me that you're not paying attention. All right, let me do Q to quit. Let me go back to this one, HTOP. Guys, I want to show you some things here. It's very important. Report yourself even to me that you're not paying attention. All right, let me do Q to quit. Let me go back to this one, HTOP. Guys, I want to show you some things here. It's very important that you pay attention because this is part of security, implementation, and management too. When I run the top command here, look at this carefully. You see even the 22.7% here cockpit right here. I can just tell him, or I can just take a screenshot and send it to him. It's not a problem, okay? Now, if I do the shift M, it filters it as well. Same thing here, not a problem. But I want you to open your eyes here, guys. Pay attention. Let's start from the top. This is the command I just ran, the top command. All right, feels good to stretch. The command I ran was top command, right? Please look up. This box has been up for 15 days, 15. Did I reboot this box too? No, it's not rebooted. It's been up for 16 days. It's been up for what? 16 days. And the time on my system is 3:46 p.m. You get it? I repeat, the time is 3:46 p.m. It has been up for what? 16 days. This box has been up running for 16 days. You believe that? If you don't believe it, let me quit from here and then we'll run the command to check. The command to check the uptime. Run the uptime. You see that? Up for what? 16 days. You know the command uptime. Uptime is check how long the system is up for running, right? Very simple. And again, please don't memorize commands. Let me go back to the top command. Here, right now, there are 7 users who are logged into the system. Oh, look at that. It's our jump box. Look up, guys. I repeat, there are 7 users who are currently logged into the jump box right now that I'm talking to you. Do you want to know who? Let me show you. So who? These are the people who are logged in. Sunny, open 2 web consoles. Sarah, you open the command line. Me, I'm on the command line as well. Julius, command line. He has 2 terminals open. He probably accessing multiple pages. And this is the root user as well. When I switch to becoming a root user. Count it. 1, 2, 3, 4, 5, 6, 7 sessions. You get that? You see that? Now, but let us leave it like this. I'll show you something. You enjoy it. Let's go back to the top command. So, load average. You see my load average? None of this number is up to 0.5 even. They are so small. This is the load average. All of this based on the CPU that I have on my system. Okay? They are doing good. How many tasks do we have? The number of tasks. There are 187 tasks in total. 1 running processes. Okay? There's 1 running process. Then there are 184 sleeping processes. You get that? We have 0 stop process and 0 zombie process. Oh, there you go. Yeah, you see that zombie? See where the zombie is coming from, right? It's right there. There's 0 zombie process, so we are safe. This is the percentage CPU usage, okay? But don't worry about any of these values. This is kind of nonsense. You don't need this value. What you need is a load average. It's more than enough. I feel like they always give too much information. But this is now for people, engineers who build, like, who design the core of the server itself, like build the kernel and set it up the way you want to run it. They use this for testing. You don't worry about this. But this is what you worry about a lot, the memory. This is the memory. This box has 16 gigabyte memory. Okay, right now we have we have 2 gig free memory space. Are you kidding me? Then we have used wait a minute. I have 16 gig. Oh, there's a lot of cache. That's why I have 16 gigabyte of memory space. I have 2 gig free, 2.5 gig free about that. I have used 8 gig, so there should be an approximate 6 gig somewhere, right? And you see, this is 6 gig. That is a cache. That is cache. Do you see how much cache we have in memory? You guys know about cache? Like, you see how bad what cache can do on your system? We have a lot of cache, and we have 5 gigabyte of cache. It's nonsense. It's a lot. I have to clean the cache. Go cd into what var log, look for the cache directory and delete everything in there. You clear your cache. Then talk about the swap. because we're talking about it too, and later on we'll talk of storage. The swap on your system, my swap is 8 gig, and 8 gig is free. None of it has been used. Okay, that's fine. Okay, not a headache. This one that says available memory, don't worry about it. Don't worry about it. This is what he's talking about. This is the memory. The swap is 8 gig. Don't worry about this. This is where you should be focused on. Free memory that can be used by the users of the system. This is where you have memory. This is the swap that is free that can be used. If your swap is used 100%, you have a problem. I'll explain it also detailedly when I get to that piece. But please, this is the part where you do the security now. Please look up, look up, look up, look up, look up, look up. Please look up. Cameras on, guys. Cameras on. Look up. This is where you apply security from this page. Right now, if they ask me, Clovis, can you tell me what the user called Sani is doing on the system? Oh yeah, I'll say yeah, no problem. When I run the top command on this page, push the letter U. When I push the letter U, you see this message. Which user do you want to see what they are doing? Right? You want to check them out, what processes they are running. I'll type the name of the user, Sani. Then I press enter. These are the things Sani is doing. You see the username, right? Everything is filtered. I have filtered all the activity that Sani is doing. And you see, Sani is working on the system, right? He has an SSH session, meaning the SSH. Press enter. These are the things, right? You want to check them out, what processes they are running. I'll type the name of the user, Sani. Then I press enter to see. On this page, push the letter U. When I push the letter U, you see this message. Which user do you want to see what they are doing, right? You want to check them out, what processes they are running. I'll type the name of the user, Sani. Then I press enter. These are the things Sani is doing. You see the username, right? Everything is filtered. I have filtered all the activity that's Sani is doing. And you see, Sani is working on the system, right? He has an SSH session, meaning the SSH to the system. He has a cockpit bridge that he opened, okay, that he's working on. I'm looking at it. He's working on the shell bash, okay? These are the things he's doing. Let's pretend that I will open this session with a different user now. Let me open as a ADM underscore, okay? Please watch this. ADM underscore GGT. Please pay attention. Pay attention because I want to show you something. Password. Thank you. Now, watch this. If I ping google.com, let's say I'm a hacker. I hack your company system, then I ping google.com. It keeps running and wasting resources on the memory of this box, right? Now, guess what? They'll ask you, Patrice, your manager is asking you to check what ADM underscore GGT user is doing because he's using a lot of memory. Then you come on this platform again, you push the letter U, you type the name of that user, ADM underscore GGT, you press enter. Then you read through everything. You see that the user has what? He's running the ping command. You see that down here? You see it? You see the name of the user right here, right? And you see how he's running the ping command. And then you know that he has an SSH session and all these other things here by default. So you'll be like, the manager is like, you know what? Please kill this process. Make sure you kill it. For this particular statement of killing, right? I need you to see this. I'll do a multi-execute thing they call it. You see, he's still pinging on the right side, okay? And I can see on the left side that, let me exclude it from here. I can see on the left side that the command ping is still running though. Oh, this is not nice. Let me see if I can reduce the size a little bit so you guys see the ping command. There you go. The ping command is still there, right here. Oh, he's running away from me, right here, okay? Now, they tell me, please go and kill whatever he's doing. Stop whatever he's doing. Watch this. I will come on the system. Here, I'll press Q to quit. Then I'll run this command, please. Kill, please look up. Kill -15. Then pay attention. Do you see the ping command? What is the ID? This is the ID for the ping command right here. That ID was, for that particular user was, that is 1,148,306. That is the ID for that particular process. When I paste it here, pay attention. I press enter. Do you see on the right side it says terminated? Whatever he was doing, I terminated it. Hello, do you see that?
Yes, yes, yes.
Very good. Now that I've terminated it, let us say the person is stubborn, because some people are stubborn, right? You know, some people don't listen. He still says, no, I want to ping Google. He goes and ping Google again. Then the manager tells you to still check what he's doing. See what I'll do. Let me exclude that. Let me include this one. So here, I'll run the top command again. Then I'll type the letter U, push the letter U, then I type his name again, ADM_GGT. I press enter. I see the ping command is still run. He still launched the ping command. And do you see that the ID has changed number? You see the ID for the ping command is different now? You notice that, right? The ID is not the same. Let me see if I can put the first ID here. That is the first ID that we had before. This is the ID, that's the ID we had before. I pasted in the chat, guys. I froze your mic. This is too much. I don't want the noise, please. Look at this. That is the ID we had before. That you had before, right? Now the manager said, please, can you make sure that you kill that ping command again? Now watch this. When they tell me that I'll type Q to quit here, then I do kill again, -9. The kill -15 is to terminate. But see what the kill -9 does. So I'll come here, copy the same ID. Please look at the left side. I'm copying the ID. You see the ID value. Let me put in the chat. You see that there's a difference between those two ID. You see when you kill a process or stop it, right? It comes back on with a different ID. It's not the same ID number. Does that make sense? So the ID is not the same, just so you know. So if I kill this one, look at the right side, what will happen? Do you notice? You see what has happened here? When I did the kill -9, what happened? It stopped everything. You see that? It did not say terminated. You dead. Because terminated is kill -15. That is soft kill. Write it down, please. Let me just explain right now since I'm here. Kill -15 is a soft kill, which is terminating a specific process or task. That is a soft kill. It means terminating a process. But kill -9 is a fast kill, which means eliminate technically everything, all records about it, like kick it out. Okay, that's the fast kill. And I'll tell you this. Let's say this user now is stubborn. I will do something else with this user. Let's say this user decides to do this. Maybe now they just want to ping. Maybe ping is the best command to use in your class because it has some stuff coming out that I want you to see. I've not taught you TCPW yet. So let's just do the ping. Let's say they want to ping CNN.com. So as they still go and they're pinging CNN, they still use the ping command. Now your manager tells you if that user runs that ping command again, make sure you kill or log them out. Stop them from having that session running. Or maybe it's a hacker who is copying documents. Okay, there's a hacker who logged in and they're copying data from a secure environment to another environment that you guys do not want. Guess what? You will go to your system, you run the top command. When this page comes up, you push letter U, then you type the name of the account that the hacker hacked into, like so. You type the account name, then you see what you're looking for. Please look up. What you're looking for is the SSH session. That is the service that gives you SSH, correct? Correct? Hello? Yes. When you log into your system, what service do you use? You use SSH, correct?
SSH.
Yes.
Exactly. Yes. So guess what? And every user who set up an SSH has an ID for that particular session. So see what you do. When you see that, you quit, then you come here, this is SSH right here. But what I'm looking for is the ID, this ID right here. Take that ID, then do kill -9. Sorry, kill space -9. Then paste that ID for that SSH. Kill it. Did anything happen here? Did that kick him out? No. How many SSH sessions do we have here? We have 1, 2, 3, 4. You see that?
4.
I have to kill all of them. That means it's not the main parent process. This is not the main one. This was not the main one I'm supposed to kill. So I have to kill all of them. So like this one. I don't want to say kill SSH. If you stop SSH service, everybody will kick out of that box. That's the worst mistake. Kill this. Do you see what happened there? When I kill that one? When I killed the one that was the parent, that was controlling the parent process itself, guess what? It locked him up. It said remove site unexpectedly closed network connection. No, it's not network connection. It is me who locked him out. Then I will run this command pass wd-l. Then I put this user parent process. This is not the main one. This was not the main one I'm supposed to kill. So I have to kill all of them. So like this one. I don't want to say kill SSH. If you stop SSH service, everybody will kick out of that box. That's the worst mistake. Kill this. Do you see what happened there? When I kill that one? When I killed the one that was the parent, that was controlling the parent process itself, guess what? It locked him out. It said remote site unexpectedly closed network connection. No, it's not network connection. It is me who locked him out. Then I will run this command pass wd-l. Then I put his username here like this. What will happen if I run this command? Down here. What will happen? What will happen?
I will lock his
account, right? I lock his password. So that means I kill his session, then I lock his password, which would mean that he cannot log in again because my manager said I should kick him out. Does that make sense? That is you implement security because you froze whatever he was doing. Now investigation can go on. You stop that malicious activity from going on. Then guess what? Now they can investigate to know what was happening, what he has done, and all that. This is security. This is based on security when it comes to your system. You will sometimes check and see what the developers are doing. Yes, that's why you guys have monitoring tool. When they tell you that the developer has accessed a file that he's not supposed to have access to, you have to jump in and check to see, right, what he's doing. If you have to kill it or report it to your manager. But we also know that there's complete session recording, so that can tell you that, right? But what if your company does not want the complete session recording? This will always be there, this aspect. You can see everything. That's why when you do sudo-i, the first time they tell you that to hear that more is given, more is expected, right? When you're getting privileged access. So be careful with privileged access, you can see what people are doing. So just respect everybody's privacy. They know that too, they tell you. So don't go and be checking people's work at work. They will know that you were checking it, okay? Don't feel like because you have the root privileges, you can just be checking things. No, let's proceed. Run the top command again. Now, please look up. There is something which I want you guys to pay attention to. Obviously, almost everything, right? But this one is very crucial. Please look up. I don't like giving this one as homework, but I feel like I should give it to you guys because this one is due on New Year's Day. That's your only thing. That's your New Year message to me. Yes, on Wednesday is due. Just send. It's gonna be 2 lines. It's a small thing. Some of you are like, no. If I offer you a job offer on New Year's Day and they pay you 150, will you say no to it? You say no. You will leave church and come and take the job before go back to church. So please let us stop talking nonsense here, okay? Let us be specific. Let's be objective too. This is small research I want you to do. Please, this is the homework. It's just a small thing. It's very simple. I don't want to just be running commands. I want you guys to do this and tell me Wednesday, please, everybody. Oh, I hope you guys do not forget that there is a $1,000 bonus for the group that will complete up to 80% of their project and they get it right. You know that, right? At the end of the course, right? It's there. What's calling me? I'm not picking calls when I'm teaching. Listen, it is there. Listen, I don't have money like that. I need more money. I don't have money like that, but I'll give $1,000 out. You know why? It's not if the project is done successfully. We might end up with nobody getting it because you guys, some students will not, groups will not do projects. Okay? Even if they're just 3 people doing that work in that group, not a problem. I don't care. But as long as it is pushed out there. Okay? And as long as you guys do at least 80% and tell me that this is what you've done, submit your work. By so saying, there's a lot more for you guys to submit to me. There's so many things you guys need to submit. Some of you are just doing like this. Then after class, you'll be like, oh, I studied STEM engineering. You study what? You're not a student. You're not even a zombie student. You're not even a zombie student. You get it? So please, let us focus and try. You'll be surprised what will happen when you go to that job. But again, just because students also get jobs, you don't necessarily do all the projects. I want you guys to do this. Just tell me what are nice values in Linux? And how can we assign nice values to a process? Very simple. It's just one command. The name of the process itself, the name of the homework is actually the command. Okay, how can you assign, I hope my spelling is correct. Even if it's not correct, I don't care. How can you assign nice values? You get it? What are nice values and how can you assign nice values to processes in Linux? Our GitHub will give you the answer, but I want you to do that and give it. So understand what it is. Nice value. If I was to give you a quick update on this one, right? These are nice values. These are the nice values. And these nice values, right? They determine the priority of a process. If you have a process that the nice values will run from -20 all the way to +20. But for the +20, you don't see plus in front of it. If you assign the priority of -20, that is the highest priority. That is the top on the list. Okay, the highest priority. -20 means the least priority. Okay, assigned to a process. So a process that has -20, guess what? That is the one that will run first. That is the process that will run first. The CPU will work on this one first. Then the one with -20 or +20, the system will work on it last. Yeah, I know the number minus and plus. You'll be like, Prof, it's supposed to be the other way around. No, it's not the other way around. It is exactly as I'm telling you. But I want you to research on it because I want you to run your command line. Just tell me that on New Year's Day. If you don't tell me on New Year's Day, I'll take out the chicken from your mouth that you're eating on New Year. Just know that. You start eating your chicken, I'll seize it. Okay? Please, let us be serious with this thing. You're playing with money. You don't know what this thing is. You have no idea. You know what it means? Somebody who does not have a degree or even high school, not in high school, is making over 170,000 on a job. And you is here who has maybe some of the degree, right? And you know what you need to do to get this thing going. You're playing with it. That is where I always get confused sometimes with students in class. I always ask myself, like, do they even know why they're in class? No, seriously. I mean, do they even know why they came to class today? Because I know they're in class, but do they know why they're in class? Okay? Because being in class is one thing. No, it's just a research. It's just one thing now. I want people to do it individually, not a group. I don't want groups. This is just to research nice values. But if you want to do it as a group, I don't mind, but put the name of those who will be in that group doing it when they are present doing it. You guys can do it tomorrow morning. It will take you less than 30 minutes to do it. 20 minutes is even too much to do that particular task. It's very simple. It's one command. I just want you to know what it is. Now, before I forget this, please, those processes that I showed you, right? this. Hey, why am I on caps lock? These processes with the IDs, right? Yes, they are here, but you see, it's annoying. You cannot see all of them here. This is not good. How do you see the processes? How can you get access to these processes? Where do we keep these processes? You get the logic in it? Now, please watch this. Excuse. There is a file that I want to cat with you. No. I'm going to gibberish. Let me zoom in, please. Or let me set it into proc so that we see it there. If we go to proc, you remember we're talking about Linux hierarchy and talking about the Linux absolute path, relative path. I talked about a few of them, and I said something about proc where we keep all processes. This is where we keep all the processes here. If I do LL, these are processes here. Now, if you come in here, you see where it says CPU info. I'll get information about CPU. Okay, now processes. Let me cut this. This is what our CPU is going through right now. Let me make it nicely. Let me just do cat proc. Proc CPU info. Then we'll open the processes as well that are running on that. Please look up. Please look up. Let me go at the top where I run it. I don't want to make it smaller. So look up. Plastic. Anyway, start from here. My CPU, this is the vendor, is the genuine Intel. Okay, the CPU family is this and all this. Why do you need to know this? If they ask you for an upgrade of the CPU, you want to upgrade CPU on that physical server, you don't have to go to the data center. You don't have to drive to the data center to give them the information. From any Linux system on the command line, if you cut the CPU info, it gives you information about your CPU here. All of this information. You do this. How do you give them this information? You don't go scroll like you don't do what I'm doing here like this. This is wrong. You don't do it like this. What you need to do to give them, cut that one, and then you append it to a file. Let's append it to a file in the 10 directory. Let's call append it to a file in the 10 this. What you need to do to give them about your CPU here. Information from any Linux system on the command line. If you cut the CPU info, it gives you information about your CPU here. The information from any Linux system on the command line. If you cut the CPU info, it gives you information about your CPU here. All of this information. You do this. How do you give them this information? You don't go scroll like you don't do what I'm doing here like this. This is wrong. You don't do it like this. What you need to do to give them, cut that one, and then you append it to a file. Do what I'm doing here like this. This is wrong. You don't do it like this. What you need to do to give them, cut that one, and then you append it to a file. Let's append it to a file in 10 directory. Let's call it maybe CPU specs. CPU specs. You see, that information will be in the file in the 10 directory called CPU specs. So if I cd into temp, I'm lazy. I wanted to cut corners. Do you see the file? This is the file right here. Do you see the file? This is the file right here. I'll email this file. I'll pull it out using the Win SCP, like I showed you last time. I'll pull this file out and send it to them. So they have the information. From there, they'll decide. You don't decide on that one. No, it's higher management. They decide which server to buy. You only talk in your low environment there, and you'll be like, but they will buy what they want to buy based on their budget. Directors decide on that one too. Okay? Please, I want you to remember this. It's very important. Then that is for CPU, but for memory, it's the same thing. Cat, etc. Oh, sorry, proc, mem info. Memory, you do mem info, like this. This is your memory information. This information for memory. Here, all this. This is information that they need. Okay. For example, like we know the total, right? The free memory and the buffer size. This is this buffer. You see, this. Look at this buffer. They ask you about buffering size sometimes or stuff. Look at the cache. This is the 5 gig cache that we have accumulated. You see, there's a lot of cache that is kept, and so on and so forth. You talk about swap as well, which is all related to supporting the memory. This is information that if they need, if they want to change quality of whatever the versions, okay, they can still pick this information and they will decide on it. The goal is, listen, when they ask you give information on memory, please. Well, how do you know the information on memory on your Linux system? Cat, proc, mem info. CPU, do that same CPU thing that does it. CPU info, please do that and send it to them so that they get to make those decisions. Does that make sense? Does that make sense? Good. Now, before because I want to show you processes, but I want to, sorry, somebody say something.
So you're asking if that makes sense. I say yes. And okay. Would you also use ls mem or ls CPU to produce that same output?
Yes, ls CPU. Just like we have ls HW to check the hardware on your system. Watch this. Before those decisions, Linux system. If they need, if they want to change quality of what kept, and so on and so forth. You talk about swap as well, which is all related to supporting the memory. This is information that if they need, if they want to change quality of whatever the versions, okay, they can still pick this information and they will decide on it. The goal is, listen. When they ask you give information on memory, please. Well, how do you know the information on memory on your Linux system? Cat, proc, mem info. CPU, do that same CPU thing that does it. CPU info, please do that and send it to them so that they get to make those decisions. Does that make sense? Does that make sense? Good. Now, before I want to show you processes, but I want to, sorry, somebody say something.
You're asking if that makes sense. I say yes. And would you also use ls mem or ls CPU to produce that same output?
Yes, ls CPU. Just like we have ls HW to check the hardware on your system. Watch this. These are the hardwares. Okay. ls. Let me do it again because I was fast. Proc, mem info. CPU, do that same CPU thing that does it. CPU info, please do that and send it to them so that they get to make those decisions. Does that make sense? Does that make sense?
So you're actually that.
Yes. Okay. LS. Let me do it again because I was fast. If you do LSHW, that means list the hardware on my system to know the hardware. Okay. This is the hardware information. It will read everything about your hardware on your system. Oh, it's cool. Wow. That's me. Let me drink my coffee.
Blessings.
Oh, thank you. There was no snow during Christmas. Is it trying to fall today? You see, even it's talking about what? PCI. You remember the PCI slot that we talked about before, guys? You know PCI or physical server was mentioned that before. Remember? You remember the PCI, right? This is the PCI bridge. So it's talking about the physical server already by giving us some information here. Okay, please pay attention. Hardware. Yes, this information should make no sense to you. Okay, but no worries. Wow, when you see somebody's thinking about you, let the person stop thinking about me. Okay, I want to focus here. Okay, so this is hardware. Now for the CPU, he was asking LS CPU. At least the CPU. This is the CPU information, but you see, it gives you this information. It's not everything, but it gives you a lot too. Remember the CPU? I don't know if we mentioned run this before, but yes, you can run this one too. Okay, you can run this.
Yeah, bro.
All right, now I want to catch a cold, so I'm doing something hot tea. Now there's something about processes that I want to speak. Please pay attention. If I run this command netstat, please look up. Netstat tells you, please, guys. Pay attention. Huh? It tells you net statistics, network statistics, right? If I run this, watch this. It tells you the network statistics for what was established, anything that was established as network is related. Port numbers, IP addresses, everything. It's a lot. It's going to show me a lot here. Okay. I did not filter it. It's going to show me a lot. So it shows me what is connected, what is not connected. I'll teach you networking. This will make so much sense. This will make a lot more sense when I teach it. But for right now, processes. If they ask you to check processes, yes, you can run the top command, but you see it's changing. It's not showing everything. To see all the processes running, please run this command ps-ef. I like ef, these flags, or you just run ps. For now, let me not use any flag. Let us go slowly. Run PS. These are processes that are running on your system. Run this command. It shows you these three processes, but it's nonsense because it's not showing you all the details. How can I tell you that all my processes running just sudo bash and PS? That's a fat lie. How about you run ps-ef now? Oops, I said PS. ps-ef. We have more. You see, it tells me who is running it or what service and the process ID. This is the process ID here. Let me go to the top where I run the command. Right here. This is the command I run ps-ef. It tells you the user ID. It tells you the process ID. This is what is important. If you want to kill it, kill this PID. It's very important. And then you know precisely what command. Let me show you with this. Let me pick an example here. I want to pick something that a user is doing. Let's go with what Sarah is doing something. This is Sarah right here. Sarah came in with SSH, right? I want to kill Sarah's session. I will just need to do this. Come here, follow this line, pick this ID, then I do kill -9, then I put that value in there. Boom, it's done. You see that? I just killed the session that Sarah was running. Or -9, then I put that value in there. Boom, it's done. You see that? It's like pick this ID, then I do kill. -9, then I put that value in there. Boom, it's gone. You see that? I just killed the session that I was running. Or if you don't like placeware because it's too much information to read, how about we make it easy? We run ps-ef. Let's say, let me start by checking who is logging. Who? Sunny is still logging. Let me kill Sunny. You see something here. So watch this. I will do this ps-ef to show all the processes. But I really want to look only the one that is related to Sunny. So I'll do grep-i, then I put Sunny. Run that. Wait, no process called Sunny. Oh, my bad. It's supposed to be -i. Sunny. You see, these are the different processes that Sunny is running. So I see everything that relates to Sunny. Now I'm looking at it, and I'm looking at what? The different services here. You see this one that says here, look up SSH right here. I can kill this to log him out, and I'll kill it. Kill that. Did I forget something? I made a mistake. Who can tell me quickly? What did I make a mistake of? What was the mistake? Sorry. I put the day.
No number.
I did not put the ID. The process ID.
The ID number.
Very good.
Process ID.
Very good. So you pay attention. Then let me kill the next one. What is the next one? To kill. I want to kill this other one as well. The second one down here, which is this ID down here. Oh, no, this one. I killed that one already. Let me kill this other one at the top. Oh, that is root. No, let me leave it like that. Let me grab again. To be sure, grab Sunny again. So I have this for Sunny. This one, this is the ID for Sunny right here for SSH. So I'll kill that -9. Then watch this. If I type who, oh, Sunny is still there on the console now. You see, he's on the console. So I have to look for the one that says cockpit console. You get it? I have to look for the one that says what? Cockpit console. Are you seeing that? Sunny is logging on the web console. Do you get the logic in it? Are you seeing that? So I have to look for the one that says web console, and I kill that. So how do I get it? Still run this command, please. This command is very powerful. ps-ef to see all the processes when you are killing stuff. Run this. You don't have to run the talk command and be seeing all those crazy numbers in front of your eyes. You get it. Run this, and then you see Sunny. Then you not look for the one that says SSHD. Look for anything that says cockpit, and I see cockpit up here. Do you see that? Cockpit bridge. So what What I'm looking for is this ID at the end here, this ID. I want to kill that ID. So I'll do kill -9. That is killed. Now, if I type again now, who, to know who is logged in, do you see one of Sunny is closed? Do you see that? We kill one of those pages that he opened. There were two before, remember? There were two like this. Now we have only one. So let us kill the second one. How do you kill the second one? Oops. Run that command again, ps-ef, grep for Sunny. Do we see any cockpit here? Do you see anything that says cockpit Sunny or anything? Do you see it? I see it. I don't know if you see it. Right here. You see it? And when I see it, what I'm looking for is this number right here, this PID. So what do? I'll say kill -9. That one, kill it. Now, if I run the command again, who? Do you see anything showing here, Sunny? Do you see any Sunny in here again? Do you see that? Exactly. So I've locked him out. Guys, make sure. All go mute. Now, how about we do the same thing for Julius? Let's do it for Julius, just so you guys enjoy it. Let us do that same PS now, that EF. I'm still coming to another one. I don't want to put that flag yet. Let's grep -I for Julius. You see, when you tell me that, oh, bro, I log in, I'm working. I'm looking at you and laughing. I know when you're working. I know you're not working. Because this will feed me information. Now, Julius login with SSH, right? These are the SSH sessions that Julius have. Here, and this one. So if I want to kill it, I just need to look for the SSH services. For this SSH, like this one down here, I need to kill this ID. Somebody will ask me the question, can I kill multiple ID? Yes, you can kill multiple, but you can do it you can write a small script for it. Okay. There's a way I can do it, but I'm not gonna give it on command line today. If I kill that, there's another Julius up here, but that's launched by the root user. There's another SSH here, so I need to kill this one as well. Kill -9. This one. Now, if I do who, do you see that Julius is gone? There's no Julius anymore. There are only 2 users. If I run the top command now, do you see at the top here, I said there are only 2 users who are logging? You see that? Look at the top, here, at the top. There are only 2 users who are logging. Right here. That is how you manage these processes and sessions. But I want now to, obviously, I will not like to end it there. I like to spice it up a little bit. Yes, how do you check Linux processes? Tell them the ps-ef command to see the running processes. Okay? Now, I want to do the same, sorry, ps, not PE, ps. Now, to see processes, you can still run this command -aux. Which is my favorite. If I run ps-ef, look at the difference between this one. Let me go up where I run the command. There you go. This is the command right here. Please look up. This is the command I just ran, the ps-ef. But this one up here is a ps-aux. Did you notice something different?
Yes.
Guys, these are flags. You see how flags can change outputs, correct? That is the goal. Look at this. How many PIDs do we have here? How many IDs do we have on the left side? On the PAUX. Down here we have PPID, we have PID. But if you look at this one up here, watch this. What do we have? Just the PID, correct? And that is what you need. You don't need the PPID to kill any process. You need just the PID. And it organizes it for you. Look at this. This again from 1. The process ID of 1 is the system D. What happens? Let me ask you this question, guys. What happens if I kill this process ID of number 1? What happens?
Your whole system will not function.
Exactly, because that is a system reason. Exactly. It's like shutting down your system. Or telling everybody that, sorry guys, nobody has to work. I like this command better than the other one because it gives you this nicely. It's better for me. Okay. You see how it gives you this information. The start, it gives you the date, December, whatever. It gives you a date very nicely. The time there very nicely. Okay. It gives you information, December 12th. That is when the system, maybe I rebooted the box, I don't know. If I scroll down, this is showing me December 13, December 16. Then anything happens December 18, it's not giving me just the time without mentioning the date. But anyway, please keep those 2 commands. Keep them safe to manage processes in Linux. Does that make sense?
So, Prof.
Yes.
So if you do kill process 1, how do you get back online then?
If you do what? If you kill the process?
Yeah, that number 1.
Which one? Oh, no,
If
you just go
you
to the box.
kill
Go to the console. Go to VMware and reboot it. Or you just go power on the box there. Okay?
Oh, okay.
Not a problem. Not a big deal. Yeah, just power on the box or restart it. Not a big deal. But I want to talk about this is for me, this is kind of the best part. What is that box? I hope the box is back online. Do we know the IP address of the box where we did the largest log server? Let me log in as root. I want to show you guys something. That's what it's wrong. This service. Just want to start it. Oh, why is it dying? Something is wrong. Run on that client. Okay, I don't blame it. What other box? I don't want to troubleshoot it. That was, let's try 228. 228 is not responsive.
24.
That was one. Is it 144?
24.
Yeah. Was it 24? Okay, let's try.
24.
I just need a box that has HTTP installed. Let's do systemctl status HTTPD. Oh, perfect. It's running. Now watch this, guys. Look up. Look up. Looking at this page, look at it carefully. This is a service that is running. Who can tell me the main process ID?
1397.
Your volume is low. Sorry, I cannot hear you.
1397.
Very true. 1397. It says here main PID 1397, and that is the HTTPD ID. If you kill this ID, the service will stop running. You get it? Who can tell me some dependent process IDs?
1671. 1671 through 1674.
Do you get it, guys? Now, if you don't know how to get it, if you don't know how to get these process IDs, right? If you cannot see it here, you just know the name of the service, right? Let's pretend that we don't know it. We are lazy or we don't know anything. Just run this command. Write this command down. PID off. So PID off, we call it. Then you put the name of the service, HTTP. Run that command. Oh, HTTPD, sorry. PID off, HTTPD, run it. Do you see all the IDs? Do you see all the IDs? This is the command you run, PID off. Then you put the service name. So if it was my